you what I'm about to say. Sunshine, she's here, you can take a break. I'm a hot air balloon that could go to space. With the air, like I don't care, baby, by the way.
This conference has been fantastic. I think having this DevOps Talk conference being run in Melbourne brings all the really good meetup groups together all in one place, and we get to listen to some really fantastic international speakers. We had a great keynote from John Willis from Docker, so it's really good to see that we get some international speakers out here. They get to talk around what's happening in the community in the international space, and then we also get to bring those thoughts and feelings from our local perspective here in Melbourne to the wider community, back to those people. I'm hoping that we'll run this again next year, and I'm hoping that out of this we'll spur on more meetups, we'll also spur on more conferences to occur. But yeah, we've got a great turnout, over 250 people. It's really, really good to see.
You don't waste your time. Here's why. Because I'm happy. Clap along if you feel like a room without a roof. Because I'm happy. Clap along if you feel like happiness is the truth. Because I'm happy. Clap along if you know what happiness is to you. Because I'm happy. Clap along if you feel like that's what you wanna do.
So I'll talk a little bit about myself first. So I am in the Docker Captains program. If you don't know what that is, have a look at it. It's really cool. So basically, we are a bunch of engineers from different places in the world that have different specialities that evangelize Docker. And through that, we get to talk to Docker engineering, work on beta projects, a whole heap of stuff. It's really cool. And that was my son. I saw put him up here because it was his 3rd birthday yesterday, and he's already thinking that he's going to start to learn the code, which is awesome. In this talk, what we'll cover is I was at a meetup, or a few meetups, and I heard people go, I can create a container, and then I can deploy it to a PaaS, and that's all I need. I don't need ops. I don't need security. I don't need anything. My application's going to be up there, and it works. And that's pretty much true, but is that what you really want to be doing? By doing that, you're alienating people that are in the operations team, in the security space, that all have a lot of experience that they could help you make your application better. So in this talk, we're going to look at the container. We're going to play with some really new stuff and some really old stuff. And we're going to look at what teams should be involved when playing with those technologies. So we're going to have a look at it like kind of backwards. Because at Puppet, I work on a team that specializes in only working on container and cloud technologies. So I don't actually work on core engineering for Puppet in Puppet Server. There's other platforms that we're building at the moment. We released one today called Lumagon. We'll kind of demo that today as well. So that's what I do at Puppet. I work solely on the container space, mostly, and a little bit to do with the cloud space. But to get an application into production, there's like lots of pieces in the container ecosystem, and there's lots of teams that should be involved to get the application up there. The container is probably the easiest part to get your application actually into a container and work it locally, but all the ecosystem that goes around that, and the teams that should be involved, and the communication that you need is probably the trickiest bit. So let's start. So first of all, we'll just look at the OS. So we've got to configure the OS. We're going to host it ourselves. We don't even know what we're going to run yet. But let's have a look at what we need. And the first thing we should have a look is we'll talk to security. And security has said to us, look, NIST has come out last week and they've got the draft for the container draft for security. And they say we should use a container-specific OS. And that's awesome. We can do that. We can run a container-specific OS because we're going to minimize our attack face. We're not going to run anything from the cloud that we don't know what's on there, so we're not going to run a Debian API, AMI, or anything like that. So already straight out of the box, when I've talking about how am I going to configure before I've even got a Docker runtime, I've spoken to security and they've said that NIST has put this out, and we're going to have to use something like that. So I decided to go with Linux Kit. And you might ask why. It's brand new. There's not a lot of documentation out there at the moment, but if you join the Slack channel on the Docker community, there is a lot of information going. And it's really cool. So what does Linux Kit give us and why would I choose that? So it's a minimal OS, which means minimal boot time. I've got the latest kernel, so security is happy. No security vulnerabilities. And also when you're running containers, consider that if you've got a vulnerable kernel, there could be possibilities of vulnerabilities within your containers itself because it is only a namespace within the kernel. If I wanted to run any container runtime on top of Linux Kit, I can. So I'm actually going to do a demo and only run containerd, runc, and an application. I'm going to run Docker itself, but I'm going to actually run it inside the container, inside runc and containerd. I'll show you the demo. With Linux Kit, the batteries are all included, but you can take them out and put whatever batteries in you want. So it's defining an OS, because all the services for the OS are containers. So you've got a service for init, you've got a service for whatever you want. You can fully rip it out and put it back. You can build it yourself. You own it yourself. So therefore, if you're owning the OS up, you can have security involved. You can have developers involved. You can actually bake your container, your application images into the OS and ship the OS as an application unit, which is pretty cool. So why would I do that? Why would I use something new like this? Well, I spoke to security, and security said this is what we should do, because they like the smaller attack surface. So the only service that I'll be running in this application is Docker itself, and Docker itself is protected from the underlying OS. It's immutable infrastructure. So if you spin it up as is, it actually doesn't even map a hard drive. It's just got a read-only file system, and you can externalize any of the data that you need, like logging or anything else, off the actual OS. And then when you deploy a new application, you can deploy a new actual OS, and the CD time to build that will be minutes, not like something like Packard that could be take quite a long time. Sandbox system services, so everything in the system sandbox. You can add all the security controls around all the different subsystems that you want. You have full control of the build, and all the configuration is YAML. So ask the question, if you are going to use Linux Kit, who actually owns it? So does security own the build? Does application developers own the build? I mean, it's YAML, they could put in what they need. Or would it be the SRE team that looks after the OS? I don't think there's a right or wrong answer to that, but it just goes to show you if you're looking at using something like Linux Kit, from the ground on up, there should be at least 3 teams talking to each other and having open communication about how to build the underlying OS. It shouldn't be a single team, a DevOps team, or any other team that's sitting there by themselves going, oh, we're going to build an OS, we're going to make this, and it's going to be great, and we're going to ship it, and everyone's going to use it, because it's probably not the best idea to do. But it just goes to show you with one simple application how 3 teams should sit down, work together, and through osmosis, we'll come up with a really solid solution. So, as you can see, it's really easy to build. You just use YAML. It looks very similar to Docker Compose, but you can put all the security controls you can with Linux onto the OS. And it runs on anything. So one of the things that you might talk about is the strategy to run multi-cloud. You can then have another team involved, maybe like your distribution team or cloud or whatever they're called, and they could say, hey, we need this to run on bare metal, we need this to run in Azure, and we need this to run on AWS. Linux Kit could run on all of those, and you could ship the same code across all clouds. So again, to use something new like Linux Kit, we're talking about having 3 or 4 teams involved. And that's, to me, what DevOps is. It's not a technology. Some people say it's tools. I think it's more collaboration of everyone together to ship a decent application that gives you business value. So now we'll just geek out a little bit because it's in the afternoon to do a demo. So that's probably really small, isn't it? Is that good? Okay, cool. So we're just going to build it. I've already preloaded it. That's okay, that's going to throw there. Okay, so that's up. So I've got my OS booted, that's it. That's all it is. And if I go up here, you can see that I've got a containerd service running. That's actually running Docker. But if you have a look, the OS doesn't know about Docker. It's hard to type with a microphone. It's not there. But if we use run C, so we just do a run, if I can spell, C exec. The application is called Docker, so you know. And then we do the Docker actual bash command, Docker PS. There's Docker. So I'm actually using run C and containerd. I don't have the Docker API or the Docker engine installed on the bottom OS. It's actually running the container that I've got sandboxed off. Now this is just a demo. This could be your own application, but I just wanted to show the segmentation that you can have. So that could be your application that needs to be segmented from another application that security is mandated. So again, building an OS, like using something new like Linux Kit, there could be multiple teams involved. Open communication, like we've heard multiple times today. And just to let you know, like this fully will work. So if we go Docker, oh no, sorry, run, and that's not spelled right. It'll pull it. That's just going to take as long as it takes for my iPad. So I just want to show that actually Docker is running. It's not just like a CLI or something like that. It is a full engine running inside the OS that's completely sandboxed off from the OS itself inside Linux Kit. So yeah, so that could be your own application, and that could be some sort of separation you need for any sort of security compliance or any other sort of regulatory needs. But it just goes to show you in just a small thing like that, that it's completely run. So if we do the other command now, so nginx is there run. So nginx, the application itself is running inside Docker, that's inside a container, running a container. It's only namespaces, right? So it's not virtualization. It's not really inception because it's just talking to the same kernel. It kind of is inception, but. But the point I was trying to get across, before I go there, is like that's how many like teams should be involved in like building something like that. So that to me is true DevOps. And I know that like that's really cool and not everyone can use it, but say you're using Debian, you could then have security mandate something like the CIS benchmark for the Docker engine. So that's got some standard vaults about how to configure the engine itself, how to protect the Docker API if you don't want to do remote deployments, how to protect the kernel from the OS and the container from the kernel running AppArmor and seccomp and all that. Now, this is an interesting problem. Security's mandated this. How do we do the configuration for this? How do we audit this? And who owns the actual configuration? Is it the team that deploys the PAS or the CAS? Is it security? Do we use the SRE team? And again, none of that, there's not a right or wrong answer. It could be different in every business. But just something as like trying to harden the actual Docker running engine will have multiple teams involved in it, or should have multiple teams involved in it. And this should be what we should be doing. We should be talking to security up front. We should be have the SRE team or DevOps, or not DevOps, but SRE team, and then give developers like code to test this with. So if you're going to harden your API in production, give them a version of a hardened API for them to develop against. If you're going to apply AppArmor profiles in production, give them the AppArmor profiles with sign-off in to develop against, so they can only run the processes that you know about. So now we've got the OS configured. If we have a look at like networking, so if we want to talk about Docker networking now, there might be another team. We might need to talk to the actual networking team. So we could have the Docker networking, there's just an example here of a reference architecture, and that's what the engine's going to look like. But what happens if we need to talk trunk VLANs through from traditional Cisco networking into Docker itself? Again, we need collaboration between the networking team and what would be the SRE team and or the DevOps team. So what I'm trying to show here is that if you want to run containers or you want to run any application, it should be multiple teams converging to talk about things that they need. Now we could have this all working, right? And it's all perfect and networking team's happy, we're trunking VLANs through and security goes, no, we need something more. We need secure communications. So we might have to change the network configuration in the overlay network, which is completely fine. But again, we've got another team come in and collaborate with us to get the right solution that we need. So there's just some VLAN trunking there of multiple containers on the same host. And now what happens if we've got a traditional sort of like operations team and we want to integrate the the DNS service discovery with something like Bind? So how do we do that? So you've got external DNS there. Obviously, we need to marry that up with what we're doing on all our different services within the container space. So there's just an example, again, of reference architecture that we would have to speak to whatever team that owned Bind to also mesh in with the service discovery that we're doing within the container space. By itself, if you don't have the multiple teams working together, you'll have like pockets of excellence, but you won't have a full end-to-end solution. So that's all on a single machine. We probably want to look at something like distributing our application. We probably want to make it highly available because we definitely don't want to have downtime. Because we heard lots of times today that people only really do DevOps or really do automation, to make sure that the customers are happy and the applications are running. So if you have a look at swarm mode, which we had a question before, I'm going to give Kubernetes some love in a second. I don't want to be vendor specific. I did swarm mode first because I like swarm better, and I've been in the swarm project for a while helping out, so I like it better. If you have a look here, it looks like some fairly standard architecture, right? But when you have a look at the internal distributed store state, what happens if you're using Docker secrets? That's something that security should be concerned about because you're passing credentials. They're kept inside the internal distributed RAF state. So when you're thinking about configuring your swarm cluster, you should have some rigor around where it's laying, what network security is, and how you're going to look at the RAF consensus group. Now, by default, we're lucky enough that Docker has got security and there's encryption across all of this. But there is stuff that you can figure yourself, like the time state snapshots, and you can actually take backups of this, like as the gentleman before me spoke about, using distributed state, you might want to test that, especially in production. So just there, like you would think, like just do swarm init, get a few worker nodes, got distributed application. But when you start to bring in things like secret that's inside the Raft consensus, also anything to do with overlay networking that will be also stored there on the host level. Security might be concerned about what sort of stuff you're keeping in that internal distributed state store. So looking at the architecture, you should be concerned with talking to security and also the people that are handling networking and also anyone that's handling site reliability, because all this needs to mesh together to give you a proper cluster. If you're going to do Kubernetes instead, there's a bit more to worry about because there's more moving parts. But again, you should be speaking to security to handle the TLS communications between Kubernetes. By default, it's not out of the box, but you should add it, definitely. Any of the communication, so with Kubernetes, you've got a few more options around things like networking stacks. You can use Weave, you can use Flannel, you can use a whole heap of stuff. Probably the team to talk to the most is the networking team and then security team about what they would need for container networking. If you need VXLAN, if you need any VLAN trunking, or VPN within the actual communications between the nodes. So we've got our application. We spoke heaps about the operations or SRE or security side of it. We had that container when we started this talk. But how do we trust what's in the container? So devs told us that there's no vulnerabilities in it, for example. There's no vulnerable packages. But how do we actually test to make sure what they're saying is true? We want some sort of quality around that. We actually released at Puppet today a new application called Lumagon. What Lumagon does is inspects an application container at runtime and does a report on it and spits it out for you for free, and you can see all the information about it. So I'll just run that now. So basically, I've cached the Lumagon container locally. I'm just going to run the report. And it should give me a URL, which I can go and see the report. Or not. Am I connected? Oh yeah, sorry. I'm going through my iPad, so you have to excuse me. It might be a bit slow. So if we copy this, and I've got like REZ and Rainbow Stream running in the container at the moment on my local desktop, so we'll just have a look at Rainbow Stream. I can see there that the kernel version it's running on. I can see the virtualization, which is the platform, so it would be the Kubernetes or Docker. I can see all the different, I can see it's like APK, so it's running in an Alpine container. And I can also see all the packages. And I can see it's actually made by Jess herself. So I'm using her container for Rainbow Stream, which is just a Twitter feed in the CLI. So if you have a look at that, we can see exactly what's in there. And if you have some sort of CVE database, you can put it against it and you can get the data out. Okay, so that was a development time and you can get the data, but what happens if you want to ship that now? Now it's production time. Now we're really getting into the thick of it and we want to get the application out there. Here's the deployment workflow. So what we probably would want is a git push of some sort of Docker file to a Git server. That would then invoke a Jenkins build. Jenkins build would then build the container. It would then should scan the container for CVEs and any known vulnerable packages. Once that's passed and you do some sort of integration testing, depending on what suite you want to do, you should then sign it and then push it to a registry. Now that I've just got Docker Trusted Registry here. It could be Quay, it could be Docker Hub, it could be anywhere you want. It could be Nexus, it could be anything. What I'm trying to show here is that they should be signed. If you created an RPM back in the day, would you send it out into your environment and not sign it? Most people would say no. You should do the same with your images. Now, once that image has gone through Quality Gate and you should be trusting it, who should own the crypto that trusts it? Should it be the SRE team? Probably not. It should be security. So you've got distributed authority over the crypto. So they can revoke it if they want to. What about the policy on how long the crypto lasts or how to revoke the crypto? All these things need to be considered. So when this looks like a fairly easy CD process, but there's a lot going on here. What about if there's a CVE on the container itself, but the business is willing to take the risk on it because there's no patch from the vendor yet? How do we work that? You can't just break the CD and not deploy the application. We've got no app now. We've got no customers. They're just getting page not found. We can't. So what about that remediation? How do we get that to the right people? So things like that we can automate. And I was brought up today. We could, for example, if the Jenkins server tried to patch it and then tried to patch it again and it failed 3 times, we could send a Slack message to security going, on this build of this container, we've got a vulnerability and we've checked CVE, there's no patch for it, is this build approved? Security can then make the decision, do they want to press OK or do they want to decline it? But we've given them the power and we've got them working with us. We haven't taken the risk on ourselves because we probably don't have the authority to take the risks on, nor do we want to take on a security risk because we might be in the SRE team. But what we do want to do is empower the people that can quickly, easily, without sort of too much human interaction, because you can communicate just as well on CD with Slack and a lot of other bots and things as you can. Because when you think about it, the security team might not be in your office. But being able to give them the privilege to be able to press the build OK or not can happen anywhere at any time. And when you start to distribute this or federate this around the world, and you have a follow the sun kind of thing like we do at Puppet, like I'm the only engineer in Australia, I need to be empowered to be able to work remotely and also in different time zones. So that could be something that you need to set up in this example. Security might not even be in your time zone. But if you don't want to break you doing further work. And security might have a process that automates that build and allows it to go out for 24 hours, and then 24 hours runs the scan again, and then says, no, we have to revoke the crypto on that because there's been a vulnerability in it for more than 24 hours. So there's a whole heap of stuff you can do inside your CD process, but if you speak to some of the security teams, they're not really aware that they can be involved in the CD process, and they really should be. They really should be involved proactively as much as a developer or an operations person, because what they're adding is no less value. If anything, it's more, and being proactive is a lot better than being reactive. So that's just an example that looks pretty simple on paper up there, but actually has a fair bit of complexity across it. And again, if we don't have multiple teams working together as one, we're not going to get a good outcome. Security's not going to be happy that they're not in control of the crypto. The SRA team might not have the right policies set up to be able to revoke the crypto if it needs to be on the trust. And there could be a whole heap of things like that. So involving everyone that understands from end to end each bit of the pie, but being able to tie it together as one, allows you to have a lot more heads in the conversation with a lot more experience of a lot more things. So collaboration wins all the time. And you can see down there, I've given the schedulers, you could use Swarm, Kubernetes, or Docker Data Center. Actually, I don't know if image shining works with Kubernetes. I'm assuming it would because it runs the Docker engine underneath, but does it work? Sorry. No, it doesn't work. Oh, no, I assume it would work because there's Docker underneath too. It's Docker doing the trust. And if we have a look here, you might want to have the developers have a look at how signing actually happens. So there's just the auth passing back and forth of how signing actually works. And then you would also have the signing, the trust on your engine. And one of the mandates from security might be that in our environment, we won't be able to run Docker run on any of the engines. And pull anything from Docker Hub. It has to come from our registry. So to get that working, you not only have the developers involved, you have the operations people that are installing Docker, configuring Docker, and then you have the trust set up end to end. So again, you've got three or more teams working for a single outcome, but together they're meshing it all together for like a better business outcome. So I'm going to give CoreOS a little bit of love here. Because I do like Claire. It was what I used to use before Docker had it in trusted registry. So if you have a look at like from a security and auditing point of view, if you put all of your logging through Jenkins, you hook Claire into Jenkins as part of the CD process, and then you sign with Notary, you've actually got an end-to-end compliance view. Security will be happy, and if you pipe that to something like Elk, where they've got a dashboard or Splunk, you actually got the security team can see everything that's happening in the builds. That same output to Splunk or Elk could have completely different meaning to someone in the development team. But they can build dashboards around the same things. Also, the development team, if something comes up in Claire and there's a package that they're using that's vulnerable, the same message goes to the developer that done the push and the security team. So the developer is actually more involved in why the build got broken. And they start to care about things like that. Before, when they were just going, oh, I just got a container, I'm just running it from like Jesse, I'm not going to patch it, just going to put my application on there, and away we go. They actually care now because their process or their build times will actually be slower because they've got to do multiple times because they've got CVEs in the actual underlying containers. So they start to think about things like, have I patched the underlying OS? Will this fail the build in the security CVE scanning? So by osmosis, you've got developers now thinking a little bit more about security or security best practices. And then again, once everyone knows it's gone through this process and the image is signed with the crypto, it can go to the engine, it runs, happy days, everyone's happy. So basically, just questions now.
Thank you for that.
That's good.
Yeah. I think only one question came through. Are you running Linux Kit in Docker or Docker in Linux Kit?
I'm running Linux on HyperKit, HyperKit, and then I'm running Docker inside that. So it was not running inside. Linux Kit was running on the bare OS of the Mac OS. It wasn't inside any container.
Cool. I think that was the only one. So thank you very much. Let's put our hands together. Okay.